Expressions of Change is a research project that aims to improve the tools by which we construct ever-changing computer programs. And it does so by putting the changes to the programs more central in the programming experience and tooling. So slogans that you might want to think of are change as a first-level citizen, or change as a primitive, or of course expressions of change itself. The first step in this project is to build an editor, and the very first version of this editor is being shown here. In the articles on the website we give a more thorough overview of some of the design decisions. Here in the video we'll just focus on showing stuff rather than telling about all the particular details. But we do want to show three things at least in this video, namely first that this is an editor of S expressions, second what primitives of change look like in such an editor, and third that these primitives can be meaningfully combined. So there's also composition over these primitives. So while I give that introduction, in the background you have actually already seen the editor in action, but it might have been a little bit quick. So the rest of this video will be the exact same thing that you've already seen, but more slowly and with each step explained along the way. So the editor is an editor of S expressions, and the reason the Wikipedia page is shown here is because we won't explain S expressions from the ground up. So if you want to know more about S expressions, read the Wikipedia page. Here we'll just stick with the executive summary, which is that an S expression is either an atom, which is another word for some kind of symbol, or it's a list of S expressions, and that this list is denoted with brackets. Returning to the editor, we can see a number of S expressions on the right-hand side of the page. So first of all, we can see the atoms, which are plus, star, 6, 9, and 12. We can also see the two pairs of brackets that each compose a different set of S expressions. For example, the innermost such pair forms the S expression, which is the list of the star, 6, and the 9. Now, of course, in a language like Lisp, you could actually evaluate this expression, but we won't concern ourselves too much with what that means here. Instead, the focus is on the construction of the S expressions, and to do so we return to the beginning of the video. So the first thing we notice is that when we start with the empty list as our first S expression. So the first step in recreating the S expression that we just saw is to add to this list a single atom, and that's the plus symbol. Having just done that, we've encountered our first two primitives. The first one being the creation of symbols, and the second one being the adding of S expressions to other S expressions. And to add sub-expressions to our expression, we simply use the third primitive, which is the creation of list expressions, which is shown here. And for the rest of the process, we simply keep using the same primitives. So here we add another symbol, and then yet another symbol, both of these to the inner expression. And then we move to the outer expression, we add a symbol to that expression, and we move back to the inner expression to add a final symbol to that expression. So none of this is very revolutionary. We've just shown how to edit the document in consecutive steps. So something that's a little bit more unique is that for whatever node we select here on the right-hand side of the page, on the left-hand side of the page we can see its history. So currently the atom 9 is selected on the right-hand side of the page, and its history is not very interesting. It is only the fact that 9 came into being. But if we instead select the root node or the root expression of our document, then we see the entire edit process that we just did in some rather cryptic form. And of course this history is precisely constructed out of the primitives of change that we're looking for. We won't go into full detail of what all these things mean, but we'll point out a few things. The symbol T means that a text symbol was added, so if there's T plus, that means the construction of the plus symbol. T star means the construction of the star symbol, etc. And time proceeds from top to bottom in this view, so we can see that we first added the plus, then the star, then the 6, then the 12, and then the 9. So that's just a very short look at some of the primitives. Now let's look at a means of combination. And the interesting new thing here is that not only are S expressions composable, but we found a way to also make the histories of S expressions composable. So here, if we look at the history of the outermost node, we see all of the history. So one of the things we can see here is that we worked for a while on the sub-expression and added the star and the 6. We went to the outer expression, added the 12, and then returned to the sub-expression to add the symbol 9. But we can also go and inspect one of the histories that this larger history is composed out of. We do this simply by clicking on a particular sub-expression, and then we get to see the history of that sub-expression only. So in this case, it's the sub-expression of which the history is to create first the star, then the 6, and then the 9. And of course the creation of the 12 is not existent in this sub-expression, and therefore it's also not visible or even existent in this history. We can even inspect the history of a single atom. It happens to be not very interesting. It only be comprised of the initial creation of that atom. So that concludes this video. We've seen the S expressions, we've seen how we can construct them and what the primitives are, and how these primitives can be combined. I hope that was useful, and more information can be found on the website, which is also a place where you can ask questions in the form of comments.